演讲呢是Hung Ying 会带给大家就是 Wasm 的介绍。我稍微用一下英文，不好意思。So, in our upcoming session, we are privileged to have Mr. Hung Ying, who will share how to use Wasm, which is a powerful runtime sandbox in cloud-native world. Let's give a warm welcome to Mr. Hung Ying. 请大家掌声欢迎Hung Ying。
Hello everyone, and I'm Hung Ying Tai, and you can call me Hai Tai. You know, the seaweed is my nickname. And today I'm happy here to share how to build and manage Wasm application use container tools at COSCUP 2023. And if you want to get this slide, I already share on the HackMD, and you can scan the QR code or just type the link here. And because, you know, I'm afraid there may be some issue that my English will be not very fluent, so I just have a recording in English yesterday. So you can click the YouTube link to get my pre-record for this talk. And today's agenda, I will share what is Wasm, okay, and how Wasm application works in container. And to let container to co-work with the Wasm, we will have two different solutions. One is use crun, and another is use run Wasm. So we will have two different plugins to use it. And then we will cover several demos for you, so you will know how to create a Wasm image, how to publish them, execute them. Even you can use Docker Compose to connect the existing database or web front end with your Wasm application. Then I will have a very short, sharing about how we integrate with the Kubernetes. So first thing is, what is Wasm? Wasm is composed of two terms, which is the web and assembly. So web is because this binary format is designed to execute some application in your browser. This is the original design. However, time changes. So now this binary format is already used in the server side, so you can execute the Wasm format on maybe on your server, on your computer, and everywhere. You don't have to execute it in the browser. And the assembly means the assembly, yeah, just like the ARM assembly, the x64 assembly, that's that. So what is the pros? And first of all, it is very secure by default because in the original design, this binary format is executing in browser, and browser is a sandbox. Okay, so every Wasm instruction will execute in the sandbox, and it's very portable. For example, you can use several modern programming languages such as C, C++, Rust, and Golang, of course, Lick, and lots of different languages to compile those language application into Wasm format. And it's completely portable cross-platform. If you are trying to build your Docker image or your container image, you will have to specify the platform. For example, you want to execute it on the Linux AMD 64 or Linux ARM 64. However, if you want to build a Wasm container, the only platform is the Wasm/Wasm. And because the container only contains the Wasm application, so the image size is very, very small. Let's say if you want to, create a very simple HTTP server, it may be less than a megabyte. And it has a fast start time and near-native runtime performance. Anyway, so how to compile it into Wasm? Actually, almost all of the programming languages are the same. You will have several languages, and you will compile into IR. For example, if you use C or C++ with the clan compiler, you will compile these languages into LLV and IR, then compile into the Wasm. And you don't need to worry about how Wasm executes on your environment, because this one, the Wasm runtime will take care of it. Just like you have a Java application, you compile the Java application into the Java bytecode. Then the JVM will execute it. You don't need to worry about which platform is executed. So we just say that everything in Wasm is in the sandbox. But we all know if we want to rewrite file, we want to open a socket, we want to do the equal or anything, actually you have to rely on the system code. So the Wasm has defined an interface we call WASI, the WebAssembly System Interface. It's just like the POSIX API. So everything you write in C, you have to rewrite it in the same way. Okay, but why is still secure? Because you have to tell the runtime which permission you want to do. For example, if you want to open a file in the current folder, you have to tell the runtime, hey, please mapping this current folder into the runtime space. If you are not doing this, you don't have the permission to read and write it. Okay, so this is the basic knowledge of the Wasm format, why we need that. Okay, and the issue is that we are not use Wasm to replace the current container. We want to do one thing is we want to work with the current application with the new Wasm application. And I have a previous talk at the SDN Cross Cloud Native Meetup 2 years ago, and at that time I present a project called the CRunW, which is the CRun plus RunW, for the run container plus the run Wasm. Okay, and we got a feedback from the audience. Audience says, "Hey, please do not add more new runtime class." Because you add a new one, I will need to handle one more. It will, make my job very complicated. But 2 years later, we already contributed back to upstream. So now CRun has the Wasm handler, and Docker already integrates our runtime. So you can see we will have two new runtime, which is the container string Wasm Edge v1 and container string Wasm type v1. So now we already have more and more new runtime class. So if you are if you're interested in Wasm and you are favoring any Wasm runtime, you can always submit the PR to add a new runtime class here. Yeah, let's make this work more complicated. So next one, we will talk about how it works. Okay, so this is a very general concept. And Docker or containerd or anything, it will execute. Actually, it will execute with the containerd string, and it will start the run C or crun, and then start your normal container. Okay, this is the normal way if you are running Nginx or the PHP or any database container image. However, if you are trying to run the image with the platform WASI/Wasm, it will try to dispatch the workload to this one, which is called the container string Wasm Edge or Wasm time v1. And the name of the Wasm Edge and Wasm time actually is to okay, so actually it's two different runtimes. So you can see here, if you are using this one, it will trigger the Wasm Edge to start the Wasm application. And also, if you use this one, it will start the Wasm time. So you have different choice. Okay, this depends on your usage and which one is your favorite. Then this one is just separate the previous graph into two because we will have a different way to work with it, which is that because there are several OCR runtime, the container string is one way. Another way is use crun. However, the crun way is different from the container string is because the crun will handle all of the workload, which means whatever is a normal container or is a Wasm container, it will always dispatch to crun, and crun will identify the platform and decide it will dispatch this workload into the crun handler or into the Wasm handler. Your Siri is too sensitive. Okay, so let's talk about the two projects. First one is Wasm, which is the Docker desktop way to integrate the Wasm runtime. And you can just click here. And this is a very alpha project. So if you are interested, please send any contribution here. We are very happy to have it. And the best idea is that because this is implemented in the container string interface, so you can use CTR, just interact with that, or just use it like the CRI plugin with your Kubernetes cluster. Okay, and please notice that this project is a POC project and is in a very active development. So if you want to use it in the production environment, just think about it. Yeah, you can try it, but time will see, okay? So this is the first one, and now it integrates the Wasm Edge and Wasm Tai, two different runtime, and the other one is the crun, which is, I said, we already upstream our contribution to here this project. And crun is, it's just a OCI container runtime, and if you are interested to add more Wasm runtime, you can go to the source folder and lib crun, which will have handlers, and just put any handler here. For example, this is the Wasm Edge, the Wasmer, and Wasm Tai. Okay, so you have one more choice. And what is the difference between crun and Wasm is that because crun will take off all of the workload first. So for example, the resource control, the settings, and almost everything is except the Wasm execution will handled by crun. So this is great. Then let's go to our demos. And the easiest way to have the environment is just install the Docker desktop. It already set up everything for you. But if you are trying to use the latest version, you may have some issue because some workload will not work. You have to go back to the previous release, which is the 4.20.1. This one, I already have this link. And after install it, you have to enable a beta feature. So let me show you. Oh, if you install the Docker desktop, you will have this screen and click settings, features in development, and please check this one. Use container D for pulling and storing image. I have no idea, but he just put the Wasm workload in this type. So please make sure, check it, and apply and restart. Then you will have the Wasm enabled Docker. Okay. So the first demo is how to create a hello world with Rust language and just package it into the Wasm container images. So you can click into this repository and the hello. Okay, so let's check the doc file first. I believe everyone sits here can understand the format of the Docker file, right? So I don't have to explain the format, right? So it will contain two parts. The first part is we have to set up the environment to build the Wasm application to build the Rust application into Wasm application. So we will use the Rust latest as our build base, and you will have to add the target of Wasm 32-WASI. This is the most important backend to enable the feature. And then we just copy file and build. This is the core content of your Wasm image. You will find scratch. Actually, it's almost empty. All you need to do is to put your application, copy from any location, and put it under your specific path. And this is the the default arguments you want to put here. So if we build and execute this image, we will get we will print the the hello from one image or something to your screen. So the application is pretty simple. We just print one line. Okay. Now let's go back to the terminal and hello first. So we will use the Docker build X build, and you have to specify the platform with. Is that clear, or I need to? Sorry. Docker build X. Hello. Okay. And you will start to build, and you will have this image here, the Wasm image demo hello. So currently is install a dependency of the Rust, and you will take some time. So if the Wi-Fi is not very well and you are use your cell phone, please do not do it now. You will take some time to download the file. Okay, so it really takes some time. So let's just kill it, and you start a run instead. Okay, I already built it, and I already published it to the Docker Hub. So let's just execute it, and you will print the string just from the application, right? And this is the first example. Oh, please, if you have an error when building the Docker image, please add this line to disable the default station. I have no idea, but this error will not occur in the 4.19 version. However, in the 4.20 version, you will need this workaround to fix the issue. Okay. So this is the first one. And if you want to publish it, it's pretty simple. Just like use build and dash push. You just build your image and just publish to the Docker Hub. That's all. And the second one is that we want to show the compatibility, how to leverage the system code in a Wasm program. Because if you are not interacting with the system code, then no real-world application can use in this container. So let's check the second example, which will do several things that we usually do in our normal life. We will try to generate a random number from the system code. You will have a random get, sorry. And actually, you want to print something to your screen, it's already a system code. Because you have to use the file descriptor to write your string into the standard output. And then we will try to retrieve the environment variables and print it, and create a file and print the file and delete the file. So everything related to the file system is still need the system code. Okay, so this example is pretty simple. And if you are not familiar with the Rust language, you can rewrite this program with C or C++ or Golang or any language already support Wasm. Just rewrite it and compile it to the Wasm format, and then just put the file into the Docker file. Then it's done. Okay, so let's try to run the second demo, the simple WASI. And the simple WASI, you can see here we generate the random number and lots of random bytes, and we will print something and get your environment variables. And this is the arguments from the default arguments. So if you want to, to add anything, for example, the COSCUP 2023 here, and you can see the argument is already passed into this application. Okay, so that you can always try it. Then the third one is that original, the Wasm don't support socket. However, if your application doesn't support socket, how you create the server, how you create the database connector. So actually, the different runtime have its own extension to add this system code into your runtime. So in this way, we have create a very, very simple HTTP server. You don't have to read the code because this is a echo server. The function it does is, it's just retrieve a string and echo the string back to you. That's all. So let's see. Docker run. I think we'll need to map the port 1234 to 1234 here. So you can find this server is star, and we can use curl to put some string into this Wasm application. And please notice that you can use Unicode. So it supports several encoding. For example, the ASCII or the Unicode is all supported. So you don't have to worry about that. And let's go in more complicated example here is we want to use Wasm as the HTTP server to handle the business logic, and then we want to store those data into database. Okay, so let's go to this, this demo here. And this example is also my tutorial in the KubeCon EU this year. So we use this example to show how to deploy the a very simple, microservice with Wasm and in your Kubernetes cluster. So let's go to the Docker Compose. You can see the logic. So we will have three different services. The first one is the Nginx. Is this? Oh, sorry, because I have not started a server, so you can not see anything. But the first one is we want to serve a web front end, so you can use a web front end to interact with your application. Then we will have the real server here is developed by the Wasm, and it will always build from the current folder. And actually, I do not, encourage everybody to put your real password in the Docker file. However, this is a demo. Please make sure this is a demo. Do not do this on your production server, okay? And we will need to specify the runtime, the platform to execute this, this business logic application, and we will start MariaDB as our database store. So this is pretty simple. All you need to do is go here and Docker compose. You just clone this project and Docker compose up. Okay, so you can see the lots of log, the database is up, and after that we're back to this website. You can see you can put the orders here. For example, let's put the first order. KCD. We will have KCD here, and we can put the second order. COSCUP 2023. Okay, and actually this is just a web front end. All of the data is stored in the database, and all you need to do is to connect the HTTP server and the database connector in your Wasm application. So you can do several complicated things in the Wasm, not only just print some string. That's not real world application. However, if you can do this one, and actually, if you are interested, we use Wasm to connect with the GPT, so we can do the the PR review with Wasm container. Yeah, so you can imagine that you can do lots of different things with Wasm, not just only very simple demo, and you can delete it. Okay, so let's false example to show how Wasm work with the normal containers. And talk to the the Kubernetes integration. I have to say, you can have lots of different solutions. Let's see. Actually, there is only a very few roles. You have KBS, you have Kubernetes, you have the CIO, you have containerd. So you have only 3 roles. However, after the combination, you will have more and more different choices. And this is just use the Kubernetes. However, somebody talked to us, hey, why not add the K3S to your demo? Why not add more and more K blah, 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 blah in your demo? And then you can find the example to a big matrix. So we are not doing that because that's too hard to maintain it. However, if you're interested, let me explain how it works. The basic idea is you can go to this repository, and we use the GitHub action to do this testing, because every time we update, it will break, always. Because the Kubernetes may not compatible with specific version of some component and blah 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 blah, such things. So we have to write a CI to cover that, to make sure that the latest version is working. Okay, and if you're interested, you can click into anyone to see what it's doing. And basically, we are, for example, if you are seeing the test is trying to print a simple WASI example. And you can see the HTTP server is just the example I just showed, the simple HTTP server. Okay, and the idea is that we just replace the, let's go to the container D and the container D configuration. Actually, we just replace the run C with C run. And this C run is the Wasm feature enabled C run. And that's all. All you need to do is to change the default runtime. And then your cluster can run the Wasm application. That's very cool. And yeah. However, this is the only way because C run is fully compatible with run C. Yeah, so you can do this way. However, if you are using the run WASI, another container string I just mentioned before, I have no idea how to enable it in this Kubernetes cluster. So if you want to try it in your local cluster, you can just apply this patch and everything will work. Also, if you have a EKS server on AWS, and you can try this one. You can try KWasm. KWasm will, because if you want to set up the environment, include the Kubernetes, include the containerd, include the CRUN, you may take too much time to do that. So you can use KWasm to simplify the stuff. Okay, so let's what we have about the Kubernetes. So that's my last slide. And we participate in the LFX mentorship this year, and we will have 4 projects. If you are interested, you can apply online to contribute your work to the Wasm Edge project. So that's all I have. Thank you.